In this video we're going to talk about design considerations for 3D printed parts. Now most of the 3D printers that you're going to use operate off of fused deposition, which means that plastic filament goes into a hot end which squirts out a very small amount of plastic, kind of similar to the way a glue gun works, and lays down the first layer, lays a second layer on top of it, and so on. Your first consideration when you're designing a piece is what part of it is going to lay on the print bed. If we examine this, you can see that the side of it with the most flat surface area is the top, right here, and I designed it that way on purpose. So as it sits on the print bed like this, I've got a nice large surface area for it to stick to. Now the next consideration is warping and curling. This piece is about 3 by 5 inches total, so warping and curling are not going to be that much of an issue. Warping happens when the plastic that is laid down on the print bed cools at a different rate across the entire piece. So the very worst thing to try to print with fused deposition would be something like a ruler, which is very long, very flat, and very thin. And what that ruler would do is, as soon as a first layer was down, as a second hot layer was put on top of it, all of the parts towards the edge that weren't insulated by the print bed would start curling up, and you would end up with a not flat ruler. And that can happen with anything that you print using fused deposition on a print bed that is not heated, does not have painter's tape on it, and even with painter's tape, curling or warping can happen. So another consideration if you're going to do something long and thin like a ruler would be, instead of printing it laying flat on the print bed, to print it up in the z-axis. And you probably wouldn't get an entire 12 inches of ruler because most commercially available printers or ones you build yourself don't have that much capacity. But if you were going to build something like a pencil, then you would want the flat end of the eraser sitting on the print bed, and you would draw the model of the pencil up, and that way it would not warp or curl nearly as much. Might fall over though. So the next consideration, once you've decided what side is going to sit on the print bed, and in this model it's this, is limiting overhang. So when we look at it from this angle, you can see that this chamfer that I put on the top is about a 45-degree overhang. And that's not that big of a deal. Most printers can handle that pretty well, because as we go up a fraction of a millimeter from this vertex, the next layer, it's not going to be overhanging that much. But if we were to orient the piece like this and try to print it on the printer, that would not work. There's all sorts of overhang now happening if the z-axis is going to be the way it's depicted. No 3D printer could successfully do that on most models without things going wrong, or with having to print a lot of support material. And if you were really fixated on doing this orientation, then you can see that you need support material down here, you need more inside this hole, you'd need support material underneath here. But with the orientation that I chose to print it like this, when you look at it from an angle, you can see that almost everything is printed straight up into the z-axis, and that's on purpose, because that's going to be the most reliable way to not have any problems. And then one last feature I want to talk about on limiting overhangs is these tabs. Now, zip ties aren't round, but I've got big round holes with for them to go through. And the reason why is I know when that prints out that doing a circle like this is going to be very easy for a 3D printer to accomplish successfully. And as it does each layer, it'll be able to get the smaller and smaller bit of overhang, and I'll have a nice solid piece that'll be able to retain a zip tie. If I had done just a rectangle, then the rectangle, the very top of it, when it got to the layer that was going to bridge the gap, problems could come up there and it might not work right. There might be loose plastic hanging down in there, and it caused me a lot of extra work when I was cleaning it up and getting it ready to go. as it is with this orientation and this design, I was able to take the piece straight off the printer and stick it into my cubicle without having to do any additional finishing work. And that's it for considerations on 3D printed parts during the design process. Thanks for watching.